All right, guys, we're going to do a little bit on types of reactions here. So depending on like what textbook you look in or, what resource you're looking at, you might see a different number of types, but I think the best way to do it is to break it down into these 5 types, okay? So I'm just going to run through each kind really quick, tell you what they are, give you an example, and then you guys are going to try on the worksheet that's posted there to tell me what kind of reaction you think is happening, okay? So let's run through it, okay? Combustion. What do you think of when you hear combustion? Hopefully you should think burning, right? And specifically it's burning with oxygen, okay? Usually these are fossil fuels or carbon-based fuels. So the products are CO2 and water. And so a combustion reaction looks like fuel plus O2 gives us CO2 and water. Okay? If you're looking for a specific example, we can look at C3H8, which is propane, like what's in your gas grill. So when you light that on fire, it burns with oxygen gas, and it gives us CO2 and H2O, okay? And then if we were to balance that, we need 3 carbons, so we're going to put a 3 there. I need 8 hydrogens, so I'm going to put a 4 there. And then that means that I have, let's see, 6 and 4 is 10 oxygens, so I'm going to put a 5 there. And that's combustion. Pretty simple, okay? Pretty simple. Next one. Synthesis, otherwise known as combination. Okay? So this is when 2 or more, I guess, elements or compounds, like 2 smaller pieces, react to form one larger substance. So if we're kind of doing like generic here, if we have like substance A plus substance B, we would get the compound AB. Okay? So an example of that would be like, I'm just trying to think here. What if we had magnesium metal, right? Solid magnesium plus oxygen gas. Remember, oxygen exists as O2 when it's sort of elemental form. It doesn't exist as just O. So what does this make? Well, it makes the compound MgO. It doesn't make MgO2, right? We'll deal with that too in a second. Magnesium and oxygen fit together 1 for 1 because magnesium has a +2 charge when it's in a compound and oxygen has a -2 charge when it's in a compound. So they fit together like this. And that's a solid, right? And then if we were to balance that, we could say that. Okay? So that's synthesis or combination. Opposite of that is decomposition. So this would be one substance breaking down into smaller pieces. Okay? So AB going to A plus B for thinking generically. Okay? And if we're thinking real life, we could give the example of aluminum oxide, which when it's heated, it breaks up into its elements, which are aluminum and oxygen. Okay? And then we just got to balance it out. So we'd need 2, 3, 4. So this would be decomposition because it's like one big thing breaking into little pieces. Okay? Last two are similar. single replacement. Okay, single replacement. So this would be when a single element reacts with a compound and switches places with something. So this would be like A plus BC, right? A single element, A, reacting with a compound, BC. And this would be like, okay, well, A and B are going to switch places. So we'll end up with B by itself and A with C. So that's single replacement because one thing bumped out one other thing. So that's one pairing switched places. Okay. A real life example of that. Let's do, what if we had sodium metal and potassium chloride, which is aqueous. Okay. When these react, we end up with potassium metal and sodium chloride. Okay. All right. So what ends up happening is the sodium and the potassium swapped places. So we started with an element in a compound, but we ended up with a different element in a different compound. That's single replacement. Okay? Double replacement, okay, is when two compounds react to form two different compounds. So this would be like AB, CD, and you end up with AD and B and C, or some combination of that, right? In other words, both substances switch partners, right? So A switched with C, B switched with D. Double replacement. Two things switch partners. So let's look at what that would look like. So that would be like, let's say KCl plus sodium bromide. Okay, they're both going to switch partners. So we end up with sodium with chlorine and potassium with bromide. How do I know it's those pairings? Well, you just got to kind of think logically, right? These are ionic substances, so you always have a positive and a negative one and a positive and a negative one. So opposites attract, right? So potassium could only go with bromine. It's not going to go with sodium because positive would repel. So this is an example of a double replacement. So when you see two compounds becoming two different compounds, that's called a double replacement. These often can have a precipitate, which is when a solid comes out of solution. We're going to do one of those in class next week, but that just gives you a sense there. Okay? So what you're going to try to do is look at a list of reactions, okay? And based on these criteria, you're going to try to identify them as one of these 5 things, okay? Go through by process of elimination. If you're not sure when you first look at it, check off the boxes. Could it be combustion? Could it be synthesis? And so on and so on and so on. And if you do it that way, you should be able to narrow it down and figure out what it is, okay? All right, have a